is the space between two intersecting lines or surfaces at or close to the point where they meet. Angles are everywhere we look. No matter what you see around you, you can probably find an angle in it. From the way you shoot a basketball, to the clock, to even pumpkin pie or the Leaning Tower of Pisa. Because there's so many different types of angles, we have to use a couple of names to classify them. The first and smallest of angles is an acute angle. It's an angle smaller than 90 degrees, but more than 0 degrees. You can remember this by calling it a cute little angle. Next in size, we have a right angle. A right angle is an angle that is exactly 90 degrees. It cannot be any more and it cannot be any less. You usually identify a 90-degree angle by the square in the bottom left corner as shown in the picture. Now that we know what acute and right angles look like, we will be able to identify an obtuse angle. An obtuse angle is an angle larger than 90 degrees but less than 180 degrees. Obtuse angles can't be greater than 180 degrees because a straight angle is exactly 180 degrees. Cannot be any more or any less. As you can see in the picture, a straight angle makes a completely straight line. However, angles aren't always what they seem to be. Do you think this looks like a right angle? It does, however, it's not. This angle equals 88 degrees. It's close to 90, but it's not exactly 90. Therefore, it's not a right angle. It's very important to be precise in math. So to figure out the measurement of an angle, we use a tool called a protractor. This is what it looks like. A protractor is an instrument for measuring angles, typically in the form of a flat semicircle marked with degrees along the curved edge. So first we're going to measure one that we already have. This is a picture of it, and we can tell that it's an acute angle, but we don't know exactly what the measurement is. So you have to make sure that this dot is on the vertex of the angle, and this line goes straight to the edge of the angle, like this side. So this one, it helps if you use your pencil to draw up to, ends up at 50 degrees. So this angle equals 50 degrees. As we mentioned before, you can create your own angle using a protractor. So what you'll do first is use the bottom as a ruler. So we'll draw a line, and then you're going to have to line that up the same way as we previously have done. So you want to make sure that the vertex of the angle is going to go right there. Now let's say that we wanted to draw an 80-degree angle. So this is lined up, and here is our 80 marker that we want to make sure that we end up at. So I just like to go ahead and draw an arrow right there, and I go on down to the vertex, just like that, and then you can use this as a ruler again to make sure that your line is straight. And there it is, an 80-degree angle. Once you understand angles, how to draw and measure them, you will be able to figure out angles of rotation. Angles of rotation are the measurement of the amount of the angle by which a figure is rotated counterclockwise about a fixed point. In this case, it's usually the vertex of the angle. Angles of rotation are useful in mapping out directions and things. So what you have to remember is that you're not measuring this angle, which is what you might normally think because that's what we often measure. Instead, you're measuring the angle at which a person turned. So imagine that someone is walking along this map that you've drawn. So normally they would go straight each time. So you draw out these straight lines from each point where there's a turn. So what we're going to measure is this on each one, because this is where they turned from going straight. So what you want to do is line up the vertex just like we just showed you, and then you're going to draw your invisible line right here, And this one adds up to 38 degrees. And you can always say, does that look right? Yes, because that is an acute angle. We can clearly tell that. Okay, and now this one, we line up down here along with this. And this one hits exactly 65 degrees. Okay, and then our last one is going to be just like the others. We line this up with that line, and the dashed line is pointing up to 87 degrees. Now, if we wanted to add up all of our angles of rotation to find the total amount of degrees that we turned from our starting point to our finishing point, we would add up 38, 65, and 87. Our answer is 190.